In a sealed letter discovered decades after her death, a woman identified only as Nikola Tesla's final assistant claims she witnessed something the world was never meant to see. According to her account, Tesla successfully powered distant lights wirelessly during a secret midnight test in 1903. Her hidden testimony, long dismissed as myth, details a moment that could have changed the world, when Tesla proved wireless global electricity was possible, and then it vanished. The historical context. By the late 1890s, electricity was already transforming the world. Nikola Tesla, thanks to his work on alternating current motors, transformers, and coils, had played a central role in that transformation. He helped build the systems powering cities with AC current, proving that electricity could be generated and distributed efficiently. But Tesla wasn't content with wires, poles, or centralized power grids. He believed electricity could be liberated, transmitted without cables, reaching anywhere on Earth. He envisioned an entirely different infrastructure, one where power flowed invisibly, effortlessly, like air or water. In that moment, electricity wasn't just a convenience, it was a universal resource, capable of reshaping how societies connected, worked, and lived. That idea, radical at the time, built on Tesla's deep understanding of electromagnetism. From experiments with his namesake transformer, the Tesla coil, and early wireless signaling experiments, he began imagining a world where the planet itself, Earth and its atmosphere, would serve as a giant conductor. Energy, messages, images, all delivered without wires. It was a dream that dared to challenge physics, economics, and infrastructure. By 1901, with growing fame but also deep ambition, Tesla set out to turn this dream into reality. He acquired land on Long Island's North Shore, a 200-acre tract in Shoreham, and prepared to build what would become the most audacious energy project in human history. The stage was set, his AC legacy behind him, the world's electrical future before him. With that groundwork, Tesla began to build, not just a tower but a manifesto for a wired-free world. The project. Starting in 1901, Tesla began construction of what he hoped would be the world's first wireless station. On Long Island, he erected a tall tower designed by architect Stanford White, topped by a massive metal dome or cupola. The tower rose to approximately 187 feet, around 57 meters, crowned by a spherical terminal meant to serve as a transmission node. Below ground lay a deep grounding system, long shafts laden with iron rods driven deep into the earth, meant to give the system a grip on the planet itself. The goal wasn't merely wireless telegraphy, though initially that was part of the plan. Tesla imagined something far greater: global transmission of electrical energy and information. His concept, sometimes called the World Wireless System, proposed using Earth and its atmosphere as a giant electrical circuit. Energy could be transmitted across continents without wires, reaching ships at sea, distant villages, or isolated homes. Such a system, he argued, could democratize energy. No more cables, no more pylons, no more infrastructure boundaries. Communication, light, all freely accessible, shared across the globe. It was a dream of connectivity and equality, where technology didn't divide but united. For Tesla, the tower was not just a machine, it was the seed of a new world. Between 1901 and 1905, the tower and laboratory rose on the Shoreham site. Generators, transformers, and experimental apparatus filled its brick building. Under the tower, grounding and conduction systems were laid. The effort consumed resources and hope in equal measure. It was bold, visionary, and unlike anything the world had seen. But dreams, no matter how grand, also carry risk. And soon, external realities began to test Tesla's vision. Tesla's goal. At the heart of Tesla's ambition was a radical technical principle, using high-frequency alternating currents and resonance to make the Earth and the layer above it behave like a vast global conductor. Instead of sending electricity through copper wires, Tesla wanted to send it through the very ground beneath us. and the charged atmosphere above us. It was a theory born from his experiments and his belief in natural conductivity of Earth and air. Tesla envisioned that the massive dome atop Wardenclyffe would establish a powerful oscillation, a standing wave, in electrical terms, across the planet. Substations, ships, even remote homes would tap into that oscillation. A bulb in London could glow the same hour a factory in New York turned on. Communication signals, telegraph, even facsimile transmission, all could ride the same network. It was a unified system of energy and information, untethered and global. The promise was staggering: universal access to electricity, power in remote areas, end of energy inequality, collapse of infrastructure barriers, a true global network for communication and industry. For Tesla, this wasn't just engineering, it was utopia. He believed the Earth, energized, would become a single living system, responsive, connected, free. Yet that promise also demanded perfection, flawless engineering, precise resonance tuning, and a planet-wide circuit that no one had ever tested. It hinged on grand assumptions about the Earth's conductivity, atmosphere behavior, and wave propagation. Assumptions that even Tesla acknowledged required further proof. But for decades, his idea fed imaginations, inspired dreamers, and cast a long shadow over what electricity, what connection could be, what reality delivered, and why Wardenclyffe ultimately failed, despite its grandeur. The reality of Wardenclyffe Tower. When construction of the tower began in 1901, supported by an initial investment of 150,000 US dollars from financier J.P. Morgan, the vision seemed within reach. The site, on a 200-acre tract in Shoreham, Long Island, included a brick laboratory building, the towering wooden structure reaching 187 feet, topped by a large steel cupola, and a deep grounding system, a 120-foot shaft with iron rods driven hundreds of feet into the earth, designed so the tower could grip the earth and send electrical pulses across the globe. By 1902 to 1903, much of the physical structure stood finished: the lab building, tower frame, and groundworks. But cracks began to show. The cost of materials, labor, and the ambitious scope drained Morgan's patience. As a younger competitor, Guglielmo Marconi began successfully sending simpler radio signals across the Atlantic using far cheaper apparatus. Investors balked. The promise of wireless messages was plausible. The promise of free global electricity was not. Despite occasional dramatic displays, locals later recalled nights when brilliant arcs of electricity leapt from the tower skyward. The system never proved stable or usable at scale. In 1905, Tesla's income took another blow. Key patents on AC motors and transmission expired, cutting off royalty payments that had helped sustain his work. With no new funds, the project ground to a halt. By 1906, Wardenclyffe was effectively abandoned. In 1917, facing mounting debts and unable to continue, the tower was demolished for scrap. The bold structure that once embodied a dream of global, wireless energy became a relic. A costly failure, sometimes called a million-dollar folly. Technical and economic obstacles. From a scientific perspective, the challenges to wireless power at Wardenclyffe were far greater than Tesla anticipated. Transmitting usable amounts of electricity over thousands of miles, through earth and air, meant overcoming enormous energy losses, unpredictable ground conductivity, and atmospheric variables. Even by modern standards, such a global resonant Earth circuit seems impractical and inefficient. Moreover, the methods Tesla used, high voltage, high frequency, AC oscillations, worked only for short-range demonstrations. In his earlier experiments, in Colorado Springs, he lit lamps wirelessly over modest distances, confirming the principle that energy could jump gaps without wires. But scaling that up to continental distances proved beyond the technology of the early 1900s. The infrastructure didn't exist, no material strong enough, no reliable understanding of global conductivity, no way to control or direct power with precision. Economically, the project made even less sense. For investors like Morgan, The goal was communication, wireless telegraphs or radios, not free electricity. Once Marconi's simpler, cheaper radio system worked, the rationale for funding a far more expensive, speculative power project vanished. Morgan and others refused to finance the ambitious pivot to power delivery. Without capital, Tesla's dream lost its foundation. Thus, Wardenclyffe stood intact but inert, a tower without purpose, a blueprint without function. Its destruction in 1917 marked the definitive end of Tesla's most audacious project. His world-free electricity remained only a dream. What Tesla actually achieved. Even though Wardenclyffe failed, Tesla left behind real, lasting achievements. His earlier experiments with the Tesla coil showed that electrical energy could be transmitted without wires. Light bulbs could glow several feet away from a power source. At his experimental station in Colorado Springs, 1899 to 1900, he produced massive voltages in artificial lightning, probing Earth's conductivity and pushing the limits of then-known electrical physics. His patents, including U.S. patent number 645,576, laid theoretical groundwork for wireless energy transmission, resonant coupling, and remote signaling without cables. Those ideas, though never fully realized in Wardenclyffe, inspired generations of engineers. In the 21st century, aspects of Tesla's thinking can be seen in wireless charging technologies, resonant inductive coupling, and early research into power delivery without physical connections. Beyond the technical, Tesla's true legacy may be his ambition and vision, the idea that electricity, communication, and perhaps even information could transcend physical cables. He challenged the status quo of wired grids, limited infrastructure, and segmented power delivery. Though his grandest goal, a global wireless grid, failed, his experiments expanded what humanity believed possible, stoked the imagination of future scientists, and fueled decades of innovation. The what-if scenario. Imagine a world where the ambitious plan had worked, a global network of towers, like Wardenclyffe Tower on Long Island, but scattered across continents and oceans, each a node in a worldwide wireless grid. No power cables, no pylons, remote villages, ships at sea, isolated communities, all drawing electricity from the air or ground. Power would flow freely to light homes, run factories, power machines, anywhere on Earth, regardless of infrastructure. Such a world could have upended energy economies. Electric utilities, fossil fuel supply lines, grid-based infrastructure might never have become dominant. Energy poverty would shrink. Industrialization could accelerate in underdeveloped regions. Communication, manufacturing, global trade, all powered without wires, cables, or the massive cost of building grids. For billions, electricity would become as natural as air or water, universal, invisible, free. The social and political impact would be enormous. Energy inequality might vanish. Wealth distribution, urbanization patterns, and global development trajectories could shift. Wars over resources, oil, coal, power might look different or never happen. Without energy monopolies, control over power would be decentralized. Electric lighting, communication, and industrial machines might spread during the first half of the 20th century, transforming everything from agriculture to education to urban planning. Yet along with utopia comes risk. A system that broadcasts electricity globally could be misused. Power surges, atmospheric instability, security vulnerabilities, unthinkable in a wired world, become possible. The very scale of the network might make it fragile. A failure at a central node could knock out power globally. Free energy could lead to overuse, environmental strain, ecological collapse. In Tesla's dream, abundance would carry responsibility, and maybe consequences no one foresaw. Despite the promise of a utopian future, reality was harsher, and soon would intervene. Technical limits, money, and human priorities turned Tesla's dream into a cautionary tale. The official dismissal. Despite the grandeur, after 1905 to 1906, Tesla's project ground to a halt. Investor support from J.P. Morgan and others dried up when it became clear that Tesla was asking for far more capital, and the promised results weren't materializing. Wardenclyffe never pushed electricity beyond short-range experiments. By 1917, the tower was demolished for scrap. Modern assessments confirmed the problems. Energy losses over long distances, unpredictable ground conductivity, atmospheric interference, all make Tesla's Earth resonance design impractical. Even with today's technology, replicating long-distance wireless power transmission in the way Tesla envisioned remains inefficient, costly, and unreliable. Over the decades, scientists and engineers acknowledge that while wireless power is possible for short distances, charging pads, inductive chargers, small devices, long-range global power distribution, as Tesla imagined, is not feasible. In technical circles, Wardenclyffe is classified as an ambitious failure, a historical footnote rather than a blueprint. The tower's downfall shows a harsher lesson. Genius and vision don't guarantee success. Without scalable, testable, repeatable results, without investor confidence, without infrastructure that can support it, even the boldest ideas can collapse under reality's weight. Tesla's dream became myth. The world moved on with wires, grids, and cables. Transition, approximately 30 words. Still, failure doesn't erase inspiration. Tesla's dream may have failed, but his legacy endured, influencing future technologies and reminding us that bold thinking matters. What history does show. Though global wireless power never materialized, Tesla's real proven legacy is vast. His work on alternating current power systems, transformers, induction motors, and high-frequency coils transformed the early 20th century and laid the foundation for modern electricity. His experiments in wireless energy, from early lab demonstrations to the conceptual design of Wardenclyffe, inspired the core idea of resonant inductive coupling, a principle now used for short-range wireless power transfer, like charging electric toothbrushes, phones, and some electric vehicles. Beyond specific technologies, Tesla's larger influence lies in vision and courage, the willingness to question the status quo, imagine radically different futures, and challenge conventional engineering limits. His failure didn't discredit ambition, it defined it. Many modern engineers and inventors cite Tesla as an icon of visionary thinking. Today, the site of Wardenclyffe is preserved by the Tesla Science Center at Wardenclyffe, functioning as a museum and educational center, a monument not just to a fallen tower, but to the power of dreaming big. Tesla's dream didn't vanish with the tower, it transformed. It lives in modern wireless charging, in engineers' ambitions, and in every questioning mind that dares to wonder, what if wires weren't necessary? The truth we know. Here is what we can say for certain. Tesla genuinely attempted wireless energy transmission. He built Wardenclyffe Tower. He demonstrated short-range wireless lighting and signaling. He filed patents. His methods sparked global curiosity. What remains unproven, despite a century of speculation, is long-distance wireless power delivery on a global scale. No verified, reproducible experiment has ever matched what Tesla envisioned. The Earth resonance concept remains theoretical and impractical. There is a gap between myth and history. Popular stories sometimes claim hidden, secret tests, suppressed successes, or lost breakthroughs. But reliable historical documentation, peer-reviewed studies, and engineering evaluations do not support those claims. Until evidence surfaces, they remain speculative. Still, the unanswered questions endure about energy, physics, ambition, and human hope. Tesla's greatest invention may not be a device, but a mindset, the belief that the impossible can be imagined, and maybe one day reimagined. Because sometimes even dreams that fail teach us more about possibility than success ever could. Her revelation reopens a century-old mystery. Was Tesla silenced? Did corporate and political powers bury a discovery that threatened their control? As the world searches for sustainable, universal power, the assistant's final words echo louder than ever, suggesting that the key to unlimited energy may have once flickered, then disappeared.